Okay, guys, so I screenshotted the questions that were picked as the most voted questions on the final review. So take a look. If you have any other ones, please ask in class. But these are the 9 that we covered or that needed the most help. So here we go. Identify the following. These are all ratios. So remember that anytime we have a trig ratio, it's going to tell you the trig ratio of the angle is equal to a ratio of sides. So for the left column, I'm trying to find of angle R. So the first thing I'm going to do is I'm going to label from angle R opposite, adjacent, hypotenuse. And if you really want to keep this in mind, we have SOHCAHTOA. Make sure that this is on your note card or your sheet of paper. Okay, so sine of R is opposite over hypotenuse, which is this side over here, opposite and hypotenuse, and the side length is R over E. Cosine is adjacent over hypotenuse, which is D over E. And then tangent is opposite over adjacent, which is R over D. Now, I have to go back to this, and now I'm referring to angle D. So from here, here's my new theta. So I need to this is not my adjacent anymore. This is now my opposite. Not my opposite, but my adjacent, still the hypotenuse. Now I find sine of D, opposite over hypotenuse, which is D over E. Cosine, which is R over E. And then tangent, which is opposite over adjacent, which is D over R. Question 7, find the arc length and the area of the shaded sector. So these are 2 formulas that have been on the board both days. Please put them on your note card for sure. And all you need is an angle and a radius. So arc length, I'm going to plug the angle in. We're trying to find the portion of the circle that 80 degrees covers. 2 times pi times the radius, which is 7. Let's plug this in our calculator. 80 divided by 360 in parentheses times 2 times the variable pi times 7, which is the radius, and we get 9.77. And we're dealing with a length, so it's going to stay centimeters. And then the area, same idea, I'm going to plug 80 because I want to figure out the portion of 360 in for theta, pi, and then 7 squared, radius squared. So if I plug that in my calculator, the variable pi and then 7 squared, and I get 34.208, so I'm going to round up to 34.21, and now we're dealing with area, so it's going to be centimeters squared. Okay, question 8, same idea. Remember that we measured these in class with our protractor. The angle was anywhere between 100 and 110, so I'm just going to use 100. And we measured the radius, which was 2 centimeters, so let's plug it in. So we get 100 over 360. Remember that goes in for theta. 2 times pi times the radius, which is 2. And we did this in class, so you should get the exact same answer. 100 divided by 360 times 2 times pi times 2. And you get 3.49. Okay, we're dealing with an arc length, so it's centimeters. And now we'll plug it in here. 100 goes in for the angle. Pi, radius, which is still 2, squared. So I get 100 divided by 360. Pi times 4, because that's 2 squared. And I get the exact same thing, 3.49. But now we're dealing with area, so it's centimeters squared. Okay, next question we wanted to pick was question 12. So here we go. Angle ABC is an inscribed angle because the vertex is on our circle. Okay, and we're given that the measurement of the arc AC is 150 degrees. An inscribed angle is always half of its intercepted arc. So the arc for ABC is AC on the circle. So it's half of that number. So X stands for 75 degrees. It's always half of the inscribed or intercepted arc. Number 15, these 2 triangles are similar. What is the value of X and Y? Well, in similar triangles, the angles are congruent and the sides are proportional. Okay, now obviously not all angles are congruent, but corresponding angles are congruent. So if I want to line up to find corresponding angles, C and F are in the same position, so angle C and angle F have to have the same measure. E and B are in the same position, so E and B have to have the same measure. And then D and A have the same measure as well. And what do you know about all 3 angles in a triangle? They add up to 360. So 80 plus 60 plus 2x equals 180. Sorry, they add up to 180. Combine like terms and I get 140 plus 2x equals 180. Subtract 140 from both sides and I get 40. Divide by 2 and I get x equals 20. Now solving for y, I need to set up a proportion. Okay, I'm going to set up corresponding sides. 2 and 4 are corresponding. 2y, and 10 are corresponding. So let's set up the proportion. 2 over 4, so from small triangle to big triangle, equals 2y over 10, small triangle to big triangle. Now we cross multiply, and I get 8y. 10 times 2, and I get 20. Divide by 8, divide by 8. Y equals 20 over 8, which simplifies. Divide that both by 4, and I get 5 over 2, or if you want to give me a decimal, 2.5. Okay, last question on this one. AB is tangent to the circle, which means it intersects at one point, which is point A, the point of tangency, and it's CA is a radius. Well, remember, whenever a tangent intersects a radius at the point of tangency, it creates a right angle. And now all we have is Pythagorean theorem. Okay, our hypotenuse is 8. It's across from the 90-degree angle. So I'm going to set up Pythagorean theorem. 5 squared plus x squared equals 8 squared. So we get 25 plus x squared equals 64. Subtract 25 from both sides, and I get 4439. Square root both sides. Square root of 39 can't be simplified, or you can give me the decimal, and we get 6.24 for our side length. Okay, questions here. Let's deal with the easiest one of the first three. So we have a triangle in our shape right here, and we should be given that this is a diameter, because we need that information. Remember, we talked about triangles before. All three angles add up to 180, so we need to find the third angle. Well, here's the deal. If this is a diameter, that means it cuts this circle into a semicircle, which is 180 degrees. And we just talked about how inscribed angles are half of their corresponding arc. Well, this corresponding arc right here is 180. So half of that makes this angle right here 90 degrees, or a right angle. So now the way to solve is we can do 90 plus 4x plus 5x equals a triangle, which is 180. Combine like terms, so I get 9x, subtract 90 from both sides, so I get 9x equals 90, and x equals 10. Okay, here are some of the toughest questions. Let's try these. Here we go. Find the area of the regular pentagon with a radius of 6. So pentagon means 5 sides. The formula is right up here. I need the number of sides for n, the side length for s, and the apothem for a. Well, I always want to try to create a right triangle. Okay, so I'm going to drop the apothem from the center. Okay, and the radius is not the apothem. The radius is from the center to a vertex. So that's this length right here. So now we have this 6 centimeters, but I don't have that much information, so I'm going to draw this out a little bigger. I have the hypotenuse, but I need an angle. So remember, central angle, I take 360 divided by the number of sides, so 360 divided by 5, and I get 72. But that's this whole angle. I don't want the whole thing, so if I divide by 2, I get this just one angle, which is half of it is 36 degrees. And now from there, I'm going to label opposite, adjacent, hypotenuse. Now I need both the opposite and the adjacent side, because I need the apothem and I need the side length right down here. Okay, so let's set up the trig. So I'm going to use sine for opposite over hypotenuse. So sine of 36 equals opposite, which we don't know, over the hypotenuse, which is 6. And then I'm going to use cosine for the apothem, or the adjacent side. Cosine of 36 equals adjacent, which we don't know, over 6. Now, because 6 is in the denominator, I can multiply both sides by 6, and that's going to have the 6's cancel out. So the opposite side is 6 times sine of 36, which is 3.53. And then I'm going to do the same thing in the other question. Times 6 so that the 6's cancel out. And the adjacent is 6 times cosine of 36. So the adjacent side is 4.85. Okay, so now we have 4.85 right here for the adjacent side, and we have 3.53. Now remember, this opposite side is just this little chunk right here. And the apothem bisects the whole side length, so it's two 3.53s. So if I take 3.53 times 2, that's going to give me the whole side length of 7.06. Okay, so now the apothem we solved was the adjacent side, 4.85. The side length was 2 of the 3.53s, which is 7.06, both centimeters. And the area of the triangle, well, the area of the triangle, this 1/2, we have the base is 7.06. It's always 1/2 base times height, so 7.06 times the apothem, which was 4.85. Let's plug that in. So 1/2 of 7.06 times 4.85 gives me 17.12. 17.12 centimeters squared, because it's an area. If I want to find a hexagon, there's 5 triangles, just multiply by 5. If not, plug it in your formula. 1/2, the number of sides is 5, the side length is 7.06, and the apothem is 4.85. Plug that all into my formula, and I get 85.60 centimeters squared. Okay, last one, find the missing information. Now we're given the apothem, so I'm going to create a right triangle. I'm going to count my sides first, 1, 2, 3, 4, 5, 6. So it's a hexagon, so I'm going to calculate this missing angle, which is 60, but I only want half of it, which is 30 degrees. So now I'm going to draw that right triangle so I can get some more space. 6, this is a 30-degree angle. I'm going to label my opposite, my hypotenuse, and my adjacent. So I can use trig. Well, I need to find the opposite because I need this side length right here. So I'm going to find the opposite given the adjacent, so that's got to be tangent. So tangent of 30 equals opposite, which we don't know, over 6, which is the adjacent. Because 6 is in the denominator, multiply both sides by 6, so 6 times tangent of 30, which is 3.46, equals the opposite side. So the half of this is 3.46, but remember the side length is 2 of them, so 3.46 times 2 is 6.92. And now we actually have enough information to find all this information. The apothem from the center to the middle of the side was given to us. The side length we found, 3.46, was half of it, so times 2 gives me 6.92. Not centimeters, just units. We don't know what they are. Okay, that's a U. Sorry about that. The area of the triangle, now we have the base and the height, so the area of the triangle equals 1/2 the base, which is 6.92, times the height, which is 6. Let's find this out. So we get 20.76. So that's the area of the triangle, units squared. And the hexagon is 1/2 number of sides times side length times apothem. So 1/2 number of sides is 6 times side length, which is 6.92, times the apothem, which is 6. Let's plug that into our calculator. And we get 124.56 units squared. 124.56 units squared. So the main thing here, you got to count the sides. Take the sides, use the central angle to find this angle, so we can use right triangle trig to find the apothem and the side length.